So now our other task is to get the first quartile and the third quartile. What do these things? This is going to give you what we call interquartile range. So interquartile range would give you 2, 3 minus 2, 1. So 2, 3 minus 2, 1. That means if I go to our calculations, we need to know what is 2, 1. What is 2, 1? So 2, 1 is the same, is actually equal to error. We can maybe call it error 2 plus 1 out of 4 n, then minus the cumulative frequency before the quartile class divided by the frequency of the quartile class times the class interval or class width of the quartile class. Then 2, 3 will equal to, maybe I call it error 2, 1. This is error 2, 3. A lower class boundary of the third quartile class plus 3 out of 4 n minus cumulative frequency before the third quartile class divided by the frequency of the third quartile class times c, which is the class interval of the quartile class. So what does that mean? You need to calculate for how you can get the 2, 1 class. So 2, 1 class will be 1 out of 4 nth value. So you also go to cumulative frequency column. So what is 1 out of 4 times 12? This would give you, isn't it 4? 4 or 3? It would give you 3.
3.
So you come to the frequency distribution table. Check in the cumulative frequency. Check in the cumulative frequency here. Where is 3?
3
is here. So you just take whatever corresponds to 3. That is 21 to 23. So that would give you 20.5 to 23.5 as the class boundary. So the class 2-1 class is 20.5, 23.5. So what would that mean? The frequency has to be read off. So frequency is 2. Frequency,
yes.
Frequency is not, let me see, frequency, yes, is required. Then the cumulative frequency is 3. Yeah, and that's all.
Cumulative frequency is not...
Cumulative frequency actually before 1. Isn't it?
1?
It's 1.
It's 1.
Yes. Okay. So that would give you error 2-1 as 20.5. Then cumulative frequency before as 1. Then frequency of the first quartile class, we said it is 3. Then the class size is also 3. So Q1 would therefore equal to 20.5 plus what? Plus a quarter of n. A quarter of n is 3 minus the cumulative frequency before, which is 1, divided by the divided by the frequency of the quartile class, which is 3, times 3, which is the class size. So this is 20.5 plus what? This is 2 out of 3 times 3. Will that give you 2?
Excuse?
Yes, please.
The frequency of that class, isn't it 2?
Frequency of the frequency is here. Or cumulative frequency is 3 and the frequency is 2. Yes. So you can see other people are sleeping. Maybe you are their spokesperson. It should give you the class spokesperson. So this is 2. So you'll have 2 out of 2, and this gives us 21.5. Isn't it?
23.5.
20?
3.5.
Because we have
Flying by 3.
Yes. So we have 1 times 3, which gives you 23.5. So Q1 gives you 23.5. Then Q3 obviously would lie somewhere also. So we need to get the we need to get the class. So third quartile class, Q3 class would be 3 out of 4 nth value. So this is 3 out of 4 times 12. What would this be? We say that this is 9. The 9th value.
It's a 9. 9.
Good. So we go to the cumulative frequency table or the frequency distribution table. We look for where 9 lies. 9 is above 8, so we can't take this. We shall take 12. Isn't it? So we will take... Yes?
8? 8 is near 9. 9 is near 8, right?
9 is near 8, but it is less.
Hey, okay.
You can't take the value which is less.
Oh, okay.
If it was like 10, we would take it. So we shall take 12. Our third quarter of the data set lies in 27 to 29. So we shall come here and say the class, therefore, class boundary, if we apply in the 0.5 and the minus plus, we shall have 26.5 to 29.5. So C would be 3. What would be the cumulative frequency before the third quartile class? And probably the frequency. The frequency is 4. And the cumulative frequency before is 8.
It's 8.
Okay. So, and okay, we're saying the frequency is 4 and the cumulative frequency before is 8. So let's come and substitute here. We are saying here is 8, and the frequency of the third quartile class is equal to 4. So now our LQ is this, LQ3. So Q3 will therefore equal to 26.5 plus. Yes. Then 3 out of 4 times 12. We said this is 9, but we are taking away CFB, which we are saying is 8, divided by 4, which is the frequency of the third quartile class, times 3. So this is 26.5 plus. This is 1 out of 4 times 3. So this is 0.75. So what is the value there? Have 0.75 plus 26.5. So the value would be 27.25 yards. That means the third quarter, in other words, it's like we are talking about median. Median is in the middle. The first quarter, a quarter of the data set, that value, it's like it's as if you're talking about the average of that value is going to be 26. I mean, it's going to be, if it is the first one, is what we got above. Then the next quarter is 27.25. Then a quarter of the full data set is going to be when we have the very last value on this data set. But what is always important is a Q1, a Q2, and Q3. Q2 gives you the median because you remember if we are talking about Q2, if it is Q2, for example, Q2 would be L of the Q2 class plus, now it will be a half N minus cumulative frequency of this class divided by the frequency of the Q2 class times C. So if I look at this formula very well, I see that this is the same as median. So when you look at it very well, you'll observe that that is median. Because this n is the sum of f. If I divide it by 2, it becomes sum of f out of 2, cumulative frequency before. Then this lower class boundary of the second quartile, you'll find out that it is going to be for the median class. So members, I think this should mark the end of our discussion. We need to talk about questions, then maybe we'll